Welcome to The Explainer. I am thrilled you're here. Let's get right into artificial general intelligence, or AGI. It is literally everywhere right now, right? Headlines, boardrooms, your social media feeds. If you've been feeling totally overwhelmed by the wild industry hype, the doomsday predictions, or the utopian promises, well, you are in the exact right place. We're going to cut straight through the noise today and look at the grounded, actual economic and technical realities of AGI. So let's just dive right in.
Here is our roadmap to tackle this. First, the definition problem. Second, the scaling hypothesis. Third, the emergence debate. Fourth, predicting the unpredictable. And finally, impressive versus useful.
Section 1. The definition problem. What are we even talking about?
We actually have to start by completely shattering a major illusion right out of the gate. You might naturally assume that the absolute smartest people in the world are all talking about the exact same thing when they say AGI. Well, they aren't. In early 2025, OpenAI CEO Sam Altman confidently said they know how to build AGI. But then, fast forward a bit, and NVIDIA CEO Jensen Huang declared, "We've already achieved it." It's kind of jarring, right? These industry titans don't just disagree on the timeline, they fundamentally disagree on the target itself.
The crucial takeaway here is that AGI is just an incredibly sloppy term right now. There's no standardized, testable benchmark for it. For some people, AGI basically just means an autonomous remote worker. But to others, it's a godlike, self-improving superintelligence. And, that vagueness is strategically brilliant if you're out there trying to raise billions of dollars, but it is completely useless for the serious scientific analysis we're doing today.
Basically, AGI acts like a giant technological Rorschach test. You look at it and you see exactly what you want to see. To a tech CEO, it's the ultimate product milestone. To a massive chip manufacturer, it's this golden marketing category. And to a philosopher, it's literally an existential threshold for humanity. So every single time you see a headline about AGI, you've got to stop and ask yourself, wait, whose definition are they actually using?
Section 2. The scaling hypothesis. Will bigger always equal smarter?
Okay, so this was the dominant engineering theory of the 2020s. The assumption was super simple. If we just keep throwing more data and more compute power at a model, it's predictably going to keep getting smarter. But then we hit late 2025. Ilya Sutskever, a co-founder of OpenAI and the architect behind models like GPT-4, flatly stated, "The scaling era is over." This was a massive shock to the system. It really revealed that while models were getting incredibly good at the specific tasks they trained on, they were totally failing to magically generalize to messy, real-world problems. Just consider this absolutely staggering number for a second. 1 in 1 million. That jaw-dropping fraction is the estimated compute efficiency of reinforcement learning compared to the earlier era of pre-training. When an AI successfully reasons through a problem using reinforcement learning, it usually just gets binary feedback, right or wrong. It doesn't actually know which of its hundreds of steps mattered. Researchers literally describe this process as trying to suck intelligence through a tiny straw. And because it's so incredibly hard to train them, the current strategy is to just give models way more time to think before they answer. This is something called inference scaling. But here's the catch. Running these AI reasoning agents can cost hundreds of dollars per hour. There literally aren't enough computer chips on the planet to make this economically viable for everyday tasks. We are hitting a hard economic wall. Because of these walls, the whole industry is essentially fractured into 3 distinct camps. You've got the optimists who believe the scaling staircase just goes up forever. You've got the pessimists who think we've hit a brick wall and need a totally new architectural breakthrough. But the most realistic view? That might be the evolutionists. They believe the path forward isn't some unstoppable rocket ship to a single superintelligence, but rather a really uneven, shifting staircase. The future is much more likely to be a horizontal ecosystem of highly specialized models all working together rather than one giant magic brain.
Section 3. The emergence debate. Magic or measurement?
So how do these capabilities actually develop inside these massive mathematical models? This is the million-dollar question that's driving all the anxiety around AGI. Are these capabilities appearing suddenly and unpredictably? The deep underlying fear here is that AI development isn't a smooth, predictable curve. People worry it's a series of sudden phase transitions, where you just add a few more parameters and then, boom, the model suddenly crosses over into dangerous, autonomous general intelligence.
Back in 2022, a Google paper argued exactly this, that new abilities like chain-of-thought reasoning just emerged spontaneously as models grew. Honestly, it felt a bit like magic. But skeptics have pushed back really hard on this. A 2024 Royal Society study argued that this sudden emergence is mostly an illusion. It's just a coarse measurement artifact. Basically, if you grade an AI with a simple pass or fail metric, a tiny underlying improvement can look like a massive, sudden jump in intelligence. These models are rigidly bounded by their training data. They are not spontaneously opening portals to superintelligence.
Section 4. Predicting the unpredictable, the timeline scatterplot.
Now that we know these technical bottlenecks, it is utterly fascinating to see how divided the absolute smartest minds in the world truly are on when AGI arrives. I mean, you have Elon Musk and Jensen Huang saying it's basically already here in 2025 and 2026, then Anthropic's Dario Amodei says 2027, but then you have Turing Award winners like Jan LeCun pointing to the 2030s, and Ilya Sutskever pushing it all the way out to 2045. That is a spread of 2 full decades. How can experts looking at the exact same data disagree this wildly?
To understand this massive gap, we really have to look at epistemology and, frankly, incentives. Get this, Microsoft actually has a contractual definition of AGI that is tied to an AI system generating $100 billion in profits. When AGI is simultaneously treated as this pristine scientific milestone and a massive $100 billion corporate payday, it's pretty safe to say these predictions are fundamentally driven by business, not just pure science.
And that leaves us in a pretty tricky position, which is summarized perfectly by a classic dilemma from the researchers at 80,000 Hours. Think about it. If 30% of experts say your airplane will explode and 70% say it won't, you don't just get on the plane. You act as if there is a serious risk. And we have to treat AI risks seriously too, even when the loudest voices making the predictions have a track record of being wrong and clearly possess financial motives for hyping up the timeline.
Section 5. Impressive versus useful. Grounding the AI hype.
Let's wrap this up with a highly practical mental filter I want you to use for evaluating all future AI breakthroughs. An AI writing a totally original novel in 10 seconds? That is incredibly impressive. But an AI perfectly and reliably processing a complex insurance claim without hallucinating a single detail? That is useful. The persistent gap between a flashy, impressive demo and a reliable, useful production system is exactly where all the real-world economic and social impact is actually going to take place over the next decade.
And because of that gap, our focus really shouldn't just be on these Hollywood-style sci-fi risks. The real pressing risks are actually quite boring. We're talking about algorithmic bias, human over-reliance, the massive concentration of corporate power, and the slow erosion of human judgment. We absolutely do not need a superintelligence escaping a data center to face immense problems. An AI that completely lacks the ability to actually think just needs to be blindly deployed by humans who treat it as if it can.
So, what's the ultimate test for true AGI? Simply put, can the system genuinely transfer understanding across domains it was never trained for? Think about how we learn. Humans can learn the spatial balance required to ride a bicycle, transfer that physical understanding to learning how to surf, and then apply that exact same spatial reasoning to packing boxes into a moving van. Current AI absolutely cannot do this. Its skills are entirely siloed. Until an AI can genuinely transfer understanding across wildly different domains like we do, true general intelligence remains a very distant horizon.
Which leaves me with a final, provocative thought for you today. The next time you read a headline boldly declaring AGI is here, are you going to passively accept the hype? Or will you stop and ask, wait, what definition are they actually using? I really encourage you to always question the Rorschach test of AGI. Evaluate the evidence carefully, ignore the noise, and keep climbing the staircase. Thanks so much for joining this explainer today, and keep learning.